Imagine you are sitting in a garden and a friend of yours is running. Motivated by her, you also start running the same direction. Now I ask you, what happens to her speed as you begin to run? Pause the video and decide your opinion on the matter.
Intuitively, the answer is quite obvious that her speed appears to have slowed down. Now if I make some change in the scenario, instead of your friend, an airplane is flying overhead and now you begin to run in the same direction. Will your answer change? If your answer is no, well, that's the correct wrong answer. If you agree with her, this clip is for you. Theoretical relationship of all the velocities involved is given by Lorentz transformation. We need not dive deep into this right now, apart from the fact that it plays a constitutive role in special relativity. This model suggests that plane should have appeared to have slowed down. Contrary to this was observed in this clip. So, did I just prove that special relativity is built on solid foundation? I should be packing my bags for Stockholm now. Whoa, come back, man. That equation is absolutely fine. Special relativity is not built on solid foundation and you are not going to Stockholm. Only issue there is with your eye. Consider this thought experiment. On a full night, you are traveling by train. Nearby trees appear to move in the opposite direction way faster than the distant mountains. The moon and the stars appear almost at rest. Let's analyze this. If you walked say 1 kilometer, then according to you, everything, including moon, has moved in the opposite direction. So after moving 1 kilometer, you will have to turn your head by some angle. That angle by which you will have to turn your head in order to find moon has got a name. It's called angular displacement. This angle by which you will have to turn your head in order to find moon, or angular displacement of moon, is so small that it comes out to be negligible for our eye. Now the really curious ones amongst you might ask, why? Why is that angular displacement negligible for our eye? Well, angular displacement by definition is inversely related to the distance between the object and the observer. Hence, the angular displacement of closest objects like trees is way higher than the distant mountains. And that angular displacement is very high as compared to moon and stars. This phenomena as a whole is called parallax effect. Here comes the climax. The strange case of plane can be considered as a resultant of two different parts. One, when plane is moving, and second, when observer is moving. When plane has moved, there is some angle made between the initial point and the end point. Whereas when observer has moved, there is a change in that angle. That particular change in angle again is not observed by our eye. But as a result of that, plane appears to have moved more than its actual distance.